All right, growth mindset math. Math side Panthers. Welcome back to part 2. On the FSA reference sheet, you'll have these formulas provided for you. The trick is, do you know which of these formulas goes with which of these sets of figures? We can call them figure shapes, so on. Let's begin with these right here, these red ones. Which of these down yonder could we use to find the area of these red ones? Well, I guess right away you can see these two are for volume, so we're not talking about volume, we're talking about area. Oh, you probably learned once upon a time, area equals length times width, whatever this side is times this side, right? Okay, but you can also use base times height. So both of those work. How about just for the orange ones? There's two answers for this, and we just went over one of them. Oops, I gave the other one away just now. How about that? Length times width. Or you can say base times height. Base times height. Base times the height. Well, what about this side right here, this green side? That's not the height. And what about this green side? That's not the height here. They're leaning. If you got time to lean, you got time to clean. So we're not using those. Get out of here. No, you. No, you. We're using this one right here. We'll make it green up and down right here. And it also, the right one, it forms a right angle. So that's the height. Base times height. That'll work for all of these, where length times width only works for these. So that's why as we get a little bit more into math, we're going to probably stop using this one so much and start using this one a lot more. Okay, let's clear the board. What's next? Triangles. Which one is for triangles? Whoops. Again, it's for area of a triangle, not for volume, so we're not quite using these yet. Well, a triangle is half of a rectangle or square. See that? And if you were to put this together, you would eventually cut out in certain ways. You would find that this space here that's white would form the same amount of space that's yellow. So the yellow is actually still half of a square or a rectangle. Anyway, so that's the deal. That's going to be half of the base times the height. Take the base times the height, divide it in half, and it's half of it. Ta-da! Process of elimination. The only thing that's left. What is this guy's right here called? These guys here for the area of these guys is that's called a trapezoid. Trapezoid. Trap. Mr. Hoffman, close your trap. No, just kidding. Bad joke. Okay, so yeah, base one, base two. There's a whole reason and an explanation how that works, but we're not going to go into that right now. For now, just know that it's this formula. And do you know what the formulas are? This one we didn't really get into. This is a ratio of circumference and radius. Actually it'd be diameter. This is just radius, go all the way across. It takes 3 of these to equal 1 time all the way around. Well, a little bit more than 3, 3.14. That's something called pi. So it takes pi of those to go all the way around. So what is this ratio? It's 3 of these for every one of those. Okay. But the ones we need to know for this are, here's that half thing or other, here's that half thingamagother, there's that base times height. It's all about that base times height. It's all about that base times height. Let's see. There we go. This breaks it down a little bit more for you, a wee bit better. Ooh, area equals pi times radius squared. That's interesting. Okay, I don't think you need to know this one right now, so let's just kind of pretend like it's not there. I can see it. Use the force. Make it disappear. Let's go. Quote of the day, quote of the week. You miss 100% of the shots you don't take. This is what's due. Check your OAMHS K12 OMHS. These is what we're trying to do today. Represent three-dimensional figures, 3D. All right, just this is 1D, one dimension, length. This is 2D, two dimensions, which is length and width, or as we just say base and height. That's not a big B though, it's a little b. Be careful because we're going to get big B a little bit later. Base times height. And then finally the third dimension. 3 dimensions. I can do a better job of throwing a three-dimensional object. Length, height, and width. Or we can say base, this is the big B, and height. We're just adding a third dimension. Rectangles, triangles, all kinds of fun stuff. Surface area. It's like if you take wrapping paper, how much wrapping paper would it take to cover a box? That's the surface area. You can also talk about the surface area of the Earth. Okay, let's do this. Oh, this is a really good video. Please check this out. Okay, so I'm not going to play this video for you here, but we will be sending you a link to this video. And we highly, highly, highly encourage you and recommend that you watch this short little and super sweet video. It's 2 minutes and 32 seconds long on nets of solids, because that's what this is about. It'll really, really make the rest of this lesson so much more effective for you. So please pause this video and go find the link to this one. It's probably going to be in your email, or it'll probably be in your newsletter or in your content. It'll be somewhere where you can find it. So find it and watch it. See you in about 2 minutes and 32 seconds. Told you it was worth it. Yeah, good stuff. Love it. Love it. Okay, let's see if you can recall from the lesson. Take a moment and match these up. Pause the video and see what you can do. Okay, what are your thoughts here? Well, my thoughts are we have prisms and pyramids. 2 prisms and 2 pyramids. And let's see. I'll start with the pyramid. Here's a pyramid. Here's a pyramid. Which of these are pyramids? And I always think of the pyramids in Egypt. So for some reason, or down in Mexico, there's like pyramids, right? Okay, this looks like a pyramid to me, but I don't know which one. Triangular pyramid, rectangular pyramid. This one also looks like a pyramid. Triangular pyramid, rectangular pyramid. Oh, one of them's a rectangle. The other one's some kind of triangle. Ooh, I see only triangles in here. Right? But here at the bottom, I see some kind of rectangle. So now I'm thinking that's a rectangular pyramid. That's a triangular pyramid. And then what's left? Prisms. Let's see. Prism, rectangular prism, and triangular prism. Which one of these has a triangle in it? There we go. Triangular prism and then rectangular prism. Here's the answer key. Okay, so what kind of prism is this? It's a rectangular prism. And what is the name of this side? What do you call a side of, just one side of this thing? It's called a face. Oh, look, there's a face, almost a face right here. You can almost see Grogu's face. Grogu is also known as Baby Yoda, also known as the child. That's going to be on the quiz. No, I'm just kidding. It's not. I wish it was on the quiz. It's not, though. I wish it were on the quiz or was on the quiz. Maybe it will be on the quiz. No, it won't be on the quiz. So here's a face after it's been all rolled out, right? That doesn't sound right, sorry. We shouldn't be rolling out people's faces, or Yoda's faces especially, not Yoda, the child. So let's just, oh, didn't mean to do all that. Let's just back this up. There we go. That's one face. But how many faces? What is the name of this shaded side of the face? How many oh, there it is. How many faces does this rectangular prism have? There's 1, 2, 3, 4. And to correspond with these, I should be highlighting the different faces over here, but I didn't do that. But if you did, like 6 sides of a dice cube, 5, 6 sides. Okay, so that has 6 sides. Okay. Ooh, this is a triangular prism? No, it's not a prism. It's a pyramid. What kind of pyramid? Rectangular or triangular? This pyramid has a rectangular base. The bottom is rectangular, so that's got to be a rectangular Pyramid, rectangular pyramid, there we go. How many faces does the solid have? Ooh, I don't know. I know there's a bottom and some sides, but I don't know how many. It's hard to say. What shapes are the faces? Well, I know one of the shapes is a rectangle, and there's like, if you were to roll it out, there'd be some triangles in there. Maybe four? I'm just guessing. All right, let's see. How are the faces arranged? I'm guessing that there's a bottom one here, and then if they fold out, I see, yeah, because this one has to, it's like a teepee. You have to connect, these have to connect. It's not like a teepee. I don't know what it's like. Like a flower? I don't know. How are the faces arranged? Okay, sketch the net. I think I just did. All right, let's see here. What are the answer keys? Ooh, there's a left face, a right face. Oh, there's a left and right. Okay, and then there's a back and a front. So that makes four, and then there's a bottom. Bottom, left, right, back, front. Let's see here. Bottom. There's no top though, right? So that's interesting. There's no top. Bottom, left, right, back, and front. That's it. Front, back, and left and right. Okay. So this is what it would look like if we were to unfold it, right? It would have the bottom. Oops, I don't know if I could color code this. We would have the bottom. We would have the left side and the right side, and we have the color should we use front and back. Oh, and there's a website you can go to open and close this. I'm going to open it up. We'll be looking at that in just a moment. Okay, this is when it's closed. Here's when it's open. Let's watch it close. Kind of go on the side. You can see what it's going to do. There's the right side, the back, left side, and then the front folds like that. Let's unfold it. Front, left side, back, right side. Ta-da! So there are 5 faces. Bottom, left, right, front, and back. Okay, what shapes are the faces? We got a rectangle and 3 triangles. How are the faces arranged? Well, again, front, back, or left, right. Did you notice this too, by the way, that this triangle here, like say the left one, is the same size as the right one, and that the front one is the same size as the back one? That'll be important at some point. There's the net. This is called a net. When you open it up, it's called a net. When you close it, it's called the solid figure. Sketch the net. Man, we've done this. Been there, done that. Ooh, draw the solid from this net. So this is a net, like Spider-Man, right? We get caught in that net. I don't think Spider-Man makes nets that look quite like this, but Grogu might. So this is, here we go. So we've got bottom, top, left, right, front, back kind of stuff in here. Let's go here and see what it looks like when we open and close something that looks like this. I'll be right back. All right, this is just one of many of the configurations you can have for a rectangular prism. It looks kind of like a T, doesn't it? Like the sort of sideways T on its back, so to speak. Okay, so what we can do here is we can call this the right side. Call that the left side. And then, of course, this green thing here is the top. Let's get those out of the way for a moment. And then you got the back and you got the front. So let's close them all. Back, front, right. Oh, don't forget there's a bottom. So if there's a bottom, there's got to be a top. This is what you need to really want to take away from this, that the bottom is the same as the top. The front is the same as the back. And then the left is the same as the right. All right, that's the biggest takeaway from this, I would say. Doo-doo! Beautiful. Okay, so now looking at this, hopefully you can kind of see, like this time it's a little bit different, but it still would fold up and make a bottom and a top, a left and a right. And I think this would be the top maybe. No, this would be the back. And this would probably be the front, probably. Let's see. Yeah, anyhow, it would fold up in the same way. Just different configurations that can make rectangular prisms. All right, let's try this one. Which solid figure could be formed from the net shown? So from this net here, if we fold it up, this one's only got 3 triangles and a bottom triangle. So this is going to make a pyramid, I bet. And a pyramid that has, looks like a triangular base. So which one of these is a pyramid Well, these two are the pyramids, right? So I think we could pretty much say no, no. But how do you know which one of these to use? Think about that for a moment. So we can see it's not the cube, it's not the triangular. Oh, wait a minute. Triangular pyramid. Wait a minute. They didn't have these in order. Because this is a prism. Rectangular, prism, cube. Wait a minute. These choices don't seem to match these up here. Cube, triangular. Why does that say pyramid? Oh, there's a triangular pyramid. They're out of order. A square pyramid or a triangular? Oh, the rectangular prism. That's a triangular prism. So these choices aren't listed correctly. So yeah, let's just, instead of these, let's just look at these down here. Let's do that, shall we? Yeah, I thought you meant like that. So we're just between triangular pyramid or rectangular pyramid. Those are our options. Let's watch over here. This, oh, look. Let's watch this and see what it looks like. Okay, here's the net. So when we start to close it, ooh, you see what's happening here? I think that's going to be the bottom. That's going to be the back, left and right, maybe, kind of thing. Yeah, so we could spin this one around. Ooh, cool. Whoa, this is fun. Oh, I got to give you guys the links to these so you can try this. This is so much fun. Wow! The force is strong with me. I feel like such a nerd. Okay. Ooh, I didn't realize you can do that. I just set it in motion. I'm gonna try that again. Oh, can I set it in a different motion? No, it seems to just go around in circles. Still kind of fun though. What if I try to do this and then set it in motion? Go. Oh, that's cool. That's a different kind of motion. Okay, getting motion sickness here. Next. Okay, so I hope we could conclude and agree that this, oops, whoa, man, I'm getting all kinds of crazy motions going on here. Bottom is a triangle. So which one of these has a triangle? This one, all triangles, right? They're all triangles. It can't be this one because this one has some kind of rectangular base. So, winner, winner, chicken dinner. If you don't like chicken, you can eat fake chicken. I do. Anyway. All right. We think we got that triangular pyramid. Yeah. All right. Match this one. Take a moment. Think about it. Pause the video so you can take a look at it. Go ahead. Press that pause button. Press the pause button. Pause for the cause. Don't make me tell you a dad joke about pause. I will later, maybe. Who knows? All right, so we're going to look at this website here to help us figure this out. You probably already have it figured out, right? Using logic and so on, spatial relationship skills. Video. Oh, here's that video you really need to watch. So good if you haven't watched it already. Oh, here's the different, oh, really quick, incidentally, while we're here, I wanted to show you how different, so we see in this one, this open, how it closes, right? And pattern 2, it can still close like that, see? And then pattern 3, man, you really gotta have fun. Check these out. I'm gonna give you the links to this stuff somewhere. Look at all the different ways they can close and still make some sort of rectangular prism. Oh, and that one. Wow, pretty neat. Again, the biggest takeaway is you got a front, a back, top, bottom, left, and right, no matter which way you open or close it. All right, enough of that. Oh, wow, we can make it smaller and bigger. Can I set it in motion? Can I move it? I think I can move it somehow. Oh, here. There it is. Oh, cool. Yo, look at that. That's so much fun. Woo, 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 woo. Getting dizzy. All right. Oh, here's the one that we're looking at now. So I think the way we're looking at it, though, is more on its side. So let's put this one on its side. Can I move it? Oh, here, grab onto this. There it goes. Pretty much like that, right? And now we can click on fold. When it folds, it's one of these kind of doohickeys. It's a rectangular prism, but all rectangles. It's not a cube. Because if we had a cube, it would all be equal sides. So if we unfold it, oh, somehow get it back like this, and set the sides to be equal. Over here, let's see, can I actually make them all equal? I think I can. Oh, I think I can. Oh, that's pretty much equal here, right? Pretty close. About as close as I think I'm going to get. Oh, yeah, if you put all these down to the bottom, there it is. Now let's see, can we zoom it a little bit? Yeah. Does that look familiar? Now we can close it. That is what it looks like if they're all equal. Oh, this is so much fun. You guys got to try this. Okay, let's go back. So yeah, which one is it going to be? Yeah, it's not going to form the cube. Nope, it's going to form this doohickey right here. And again, big takeaway for me, just do this, please. You got a left and a right, you got a front and a back, and you got, let's see, what color haven't I used yet? Red, a bottom and a top. Okay, now match the solid figure to the net. So over yonder, here's the solid figure. Which one of these matches that net? And there's a site right here you can go to and try it. Yeah, that's what I should do, is I'll just make these available for you to try. Go try it. Go click up, find this one here, and see, what should we call it? I didn't really think I had too much on this. It has the Z39 in it, maybe? We'll just call it number 1 because it's the first time I told you to go to it. So it's the link 1. Call it link 1. Oh, you back already? Okay, because you know this is also something that will help you too if you think it's going to be one of these. And do you really need to go to these at all? I mean, can you just look at it and see that, hey, excuse me, Mr. Hoffman, this has a 1 triangle, 2 triangles. That's it. There's 2 triangles. And these other sides are not triangles. These are like all rectangles, so it's this one. Spoiler alert, too late. Oh, yes, so in your OMHS quiz, you have a problem like this. Basically, they're saying, well, if you know one side is 3, and this is a cube, that means all the sides are 3, right? So if this side is 3, then this side is 3, all right? And so that's all you need to find the area of this one right here is 3 times 3, which is 9. If you know one of them's 9, you know they're all 9, 9, 9. Mine? Finding Nemo? So here, I'll just break it down in some more visuals for you. Faces of cubes. Notice there are 6 of them, by the way. So basically all we're doing is we're squaring one side and then multiplying by 6 in the end of this. That's the formula, the rough version. So see, this matches this. 3 by 3, that means 9. 9 little tiny what? Millimeters. So there's a square millimeter, there's a square millimeter, there's a square millimeter, there's 9 square millimeters here, or 9 millimeters squared. 9 millimeters squared. And there's how many of those? 6 of them. So take the 3 times 3 times 6. 9 times 6. 6 sides. Yes, 54 millimeters squared. So there would be 54 of these little things here. 1 millimeter by 1 millimeter by 1 millimeter by 1 millimeter. That's a square. 1 millimeter square. Got it? Okay. All right. So what would this be? Pause the video. You're back so soon? What'd you get? Did you get this side 20? This side is 5. If this side is 5, since it's a square, they're all 5. And that's all you need. 5 times 5 is 25 here. How many 25s are we going to have? 1, 2, 3, 4, 5, 6 25s. And if you're writing them on here, you could see 3 of those 6 sides. You can only see 3 of them. 1, 2. Oh man, I'm having a hard time. Come on. 3, and then the other 3 sides. So it's really 25 times 6. Oh, what is 25 times 6? Yeah, if you want to know, it's just here. Give me my pen. 25 times 6. See, that's 30. That's 6 times 2 is 12, 13, 14, 15, 150. 150 inches squared. That's how much it would take to cover up all of this stuff. It's like 5 on this side, 5 by 5. So there's like 25 squares here, 25 here, 25 little square inches here, and then on the other 3 sides too. Ooh, find the surface area of this one. Pause the video. Give it a shot. Go ahead, press pause. Pause for the cause. Don't make me tell my pause joke. We're 25 minutes into this already. This is taking way too long, right? If you're still here. 4 times 4 is going to be the middle side, right? Because this side is 4 and this side is 4. That means I'm going to have 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 squares in here, which are meters. And then I'm going to have 4 equal triangles. A triangle is, remember, half of the base times the height. You can't see it, but this base here is 4. See? 4. The height is the right angle one, this one, 6. Half of 4 times 6. Half of 4 times 6. 4 times 6, 24. Half times 24, it's half of 24. What's half of 24 is 12. So that's 12. But how many of those do we have? We have 1, 12, 2 12s, 3 12s, and 4 12s. And don't forget, we also have 4 times 4 here for this square, which is 16. 16 plus 12 plus 12 plus 12 plus 12. Okay, add them all up. 16 plus 12 plus 12 plus 12, 64 meters squared. Here it is again in kind of a review here. Area equals S squared. Side squared. So whatever one, that's the area. This is the formula for the area of a square. S squared. You take one side and square it. So 4 squared is 16. But you could just say 4 times 4 and still get 16. Just saying, okay? See? Watch, I'm still going to get 16. The area of the square is 16 meters squared. The area of the triangle is base times height divided by 2. Take half of it. We get 12. See? Same thing. Just add it all up. 64 meters squared. You try this one now. We're almost done, by the way. Hang in there. How'd you do? See, this is a square. If this is 5, the base is 5, then the height is 5. 5 times 5, 25 inches squared. Now we have identical triangles. So once you find one of them, you know them all. Half base times height is the way you find the area of a triangle. Base times height. The base is 5. If it's 5 here, it's 5 here because this is a square. All sides are equal. 5 inches. Height is 6. Has that right angle. The height is right. And so we have half of 5 times 6. And I'm going to show you a little trick here. You may or may not like this, but I love it. I love it. I'm going to take this half and 6. I'm going to take half of 6. Right? And then I still have the 5. I have to deal with the 5 there. But I want to take the half of the 6 first. What's half of 6? I know half of 6 is 3. But I still have this 5. So I'm just going to bring the 5 right down here. See? And then I can multiply. 5 times 3 is 15. So each triangle is 15 inches squared, right? See, if I did it the other way, what if I said, oh, wait a minute, does it still work? Are you sure, Mr. Hoffman, about that? It will. Watch, if you do the 5 times 6 first, you get 30. What's half of 30? It's still going to be 15. I think this way's a lot easier and smarter. Smarter, yes. strategery. That's not, I don't know if strategery is a word, but it's fun to say. Try it. Okay, so where did we say? 15. So that's 15. This is 15. This is 15. This is 15. I want to add them up. I'll be right back. You try it too. Okay, so I've got 85 inches squared. Did you get that? I hope so. It's all right. Next. Almost done. This one looks like fun. Find the surface here, this figure. Remember the big takeaway? Can you find which is the bottom? Because once you know the bottom, then you could probably find the left and the right, then the top and the bottom, and the top, bottom, and left, right. Oh, front and back. Try it. Okay, I'm going to say that this is the bottom. I'm pretty sure. When you fold it up, it'll be the bottom. All right, because the bottom is going to be connected to the left and the right. When you fold them up, this is the left, this is the right. They're going to be the same. And then that means that the front, let's make the front green. And the back will be green, right? This will be the front when it folds up. This will be the back. That's got to be the same. And then the only thing that's left is the top, the TOP, which is the same as the bottom. So let's go back to the blue. Now, so once you find one, you found two. So this is base times height, 5 times 3 equals 15. So this is 15 inches squared. If this is 15 inches squared, so is this one. 15 inches squared. Let's do this one. All right. Well, maybe we better do left and right first, because this one's easier, right? You can do 2 times 3 is 6. So this one's going to be 6. If the right is 6 inches squared, the left is 6 inches squared. All right, now this is the tricky one. I know this is going to be 5, but how do I know what this is right here? That's the tough one. I do know when they fold that this side will match with this side when you fold them. Go ahead, go to the site, try it out. You'll see what I mean. Go ahead, the fold up. This will match this side. So whatever this side is, it's going to be the same as this side. Oh, and look, whatever this side is, it's going to be the same as this side because these two match together. So that's 2, so this is 2. If that's 2, then this is 2. They're all 2. So now I can do 5 here, 5. Oh, that's not a good way to do it. Let's try this. Here we go. This 5 here times this 2 here. 5 times 2 is 10. That's it. So if this is 10 inches squared, this is 10 inches squared. Add them all up. Add your 2 greens, your 2 purples, and your 2 blues. The top, the bottom, the top. The left, the right, and the back and the front together. Okay, I'm going to kind of cheat, sort of, and do some of this in my head because I knew, for example, 10 and 10 is 20. So I'm just going to put 20 here. And I'll put a little green on there to know that that's my front and my back. Then I know that 6 and 6 is 12. So I'll put here, that's my left and right here. My left, my right, that's my purples. And I know that 15 and 15, the blues, I got 2 blues. I got more than 2 blues. I got lots of blues. And that's going to be 30. Now it's easier to add 2. 560, 62 inches squared. Oh, do we really need to do more? Let's see what's left. That's the end. I think you've got enough to go on. Just be careful with this one. Remember, when you fold this, you're like, how can we do this? They don't tell us all the sides. Think of what it looks like when it's folded. That'll help you a lot. If you know one, you know a bunch of them. You know if this is the bottom. You know this is the top. This would be the front, this would be the back, this would be the left, this would be the right. Hut, hut, hike. Same thing here. All right, we're done. Pride, passion, purpose. Peace out, Panthers.